Here is a problem from JEST 2023. We have to compute the integral I is equal to integral t1 to t2 r cross a dt. Here we have a cross product and we have to compute the integral of this cross product. The first thing that we have to recall here is that cross product obeys the integration by parts, but the order of vectors is important. Therefore we have I is equal to first vector cross integral of second vector within the limits t1 to t2 minus integral of derivative of first vector cross integral of second vector. Then you have to integrate this. Now we know that a is equal to, acceleration is equal to derivative of velocity with the time, and also dv by dt times dt integral, this is equal to v. Therefore we have I is equal to r cross v within the limits t1 to t2 minus integral t1 to t2 dr by dt is v cross integral a dt is integral dv by dt times dt, which is v dt. Now v cross v, this is equal to 0. Therefore we have I is equal to r cross v from t1 to t2. This is equal to r at the time t2 cross v at the time t2 minus r at the time t1 cross v at the time t1. Now in the question it is given that the position vector at the time t1 is r1, the position vector at the time t2 is r2, the velocity at the time t1 is v1, the velocity at the time t2 is v2. Therefore if we substitute these things here, we will get I is equal to r2 cross v2 minus r1 cross v1. Therefore the correct option here is option A.